Alright, in this section we're going to simplify rational expressions, and we're going to do a lot of these by factoring out greatest common factors. So in this one here, I look at the coefficients, 18 and 36. I try to find a common factor between 18 and 36. Well, they're both even, so they're divisible by 2. I think 3 goes into both of those, so does 9, and actually 18 goes into both 18 and 36 because 18 times 2 is 36. So what I can do is I can divide these both by 18. When I divide 18 by 18, I end up with a 1. And when I divide 36 by 18, I end up with a 2. Now I'm going to look at my x term. So this is x to the 4 on top and x to the 7 on bottom. So this is really the same as having 4 x's in my numerator multiplied together and having 7 x's in my denominator all multiplied together. So when you write them out like this, 1, 2, 4, 6, 7, what you might notice is that you've got pairs canceling each other off in the numerator and denominator. And this leaves us with 3 x's down in the denominator. So to get my final answer, I just put x cubed down here. Another way of getting this answer is doing 4 minus 7, which gives you negative 3. So then you'll have x to the negative 3 over 2. And then to make this a positive exponent, you just bring it down into your denominator. So that's an alternative explanation for that one. So now for this one here, I need to find out what a common factor is in my numerator. I'm ignoring the denominator to start. So for my numerator, 3 and 9 are both divisible by 3, so my common factor would be a 3. I've also got a y and a y squared, so my common factor would also have a y. So now to find out what goes inside of the bracket here, I need to find out what multiplies by my greatest common factor to give me this numerator. So 3y times what gives me 3y? Well, 3y times 1. 3y times what gives me negative 9y squared? So that would have to be negative 3y. Then I'm going to write my denominator down. And now, since I have multiplication involved, I'm going to put brackets around this. So it's 3y times 1 minus 3y. I can cancel between these guys. I can't cancel within a bracket like this. I can only cancel the whole bracket with another whole bracket. So if I had another 1 minus 3y down in the numerator here, then they would cancel off. But since I don't have another 1 minus 3y, I can't cancel this off. It's going to be left over. I can, however, reduce with these terms here, because 3 and 6 have a common factor of 3. So when I divide them both by 3, this is going to give me 1, and this is going to give me 2. I've got y and y cubed, so similar to the last example, 1y on top and 3 y's on bottom. So this y cancels with one of these, making that y squared. So then what am I going to be left with? Well, this term is just left with a 1. This bracket ends up hanging around. My denominator ends up becoming 2y squared. So for my final answer, I can remove the brackets here because this is just a 1 and give 1 minus 3y over 2y squared. So that will be your final answer for that one there. So now for the next one, let's look at an example where both the numerator and the denominator have binomials in them. So an example would be 6x squared minus 8x over 3x cubed minus 4x squared. In this case, what I'm going to do is find the greatest common factor for the numerator, then find the greatest common factor for the denominator, and see if I can get anything to cancel out. So 6 and 8. Well, both of those numbers are divisible by 2, so my common factor will be 2. X squared and x, they both have an x, so my common factor in the numerator is 2x. So now to find out what goes inside the bracket, I need to find out what multiplies by 2x to give me 6x squared minus 8x. So 2x times what gives me 6x squared? Well, 2 times 3 gives me 6. And then x times x gives me x squared. Okay, now 2x times what gives me negative 8x? Well, that should be negative 4. All over. Common factor for the numerator, 3 and 4 don't really have a common factor besides 1. So I'm going to look at my variables, x cubed and x squared. So the lowest exponent that you see is your common factor. So in this case, my common factor could be x squared. And x squared, if you want, you can write the 1 here so you can see it. X squared times what gives you 3x cubed? Well, 1 times 3 gives me 3. And x squared times x gives me x cubed. And x squared times what gives me negative 4x squared? Well, that would be negative 4. So in this instance here, you can see that inside the brackets I have the exact same term. This means that they can cancel each other off. To cancel brackets, both brackets need to be exactly the same. When I look at this one here, I've got 2 and 1 I can't do anything with, but x and x squared, so I can see that this x is going to cancel off one of those, leaving me with just an x there. And I think that's about it. So our final answer then, for my numerator, I just have 2. And for my denominator, I just have x. So my answer here is 2 over x. Alright, so let's look at another one like that and see how that one goes. So the next one, 3a cubed minus 3a squared over negative 12a plus 12. Take my common factor from my numerator, 3 and 3, common factor quite simply would be 3. A cubed and a squared, my common factor is the lowest exponent, so that would be the 2 here, so a squared. 3a squared times what gives me 3a cubed? Well, I've got the 3 already, so 3 times 1 gives me 3. I've got 2 a's here, but I need 3, so that tells me that I need another one, another a. And 3a squared times what gives me negative 3a squared? Well, that would be a negative 1. Over. Looking at my denominator here, I've got negative 12a plus 12. There are actually a couple ways you could deal with this, but for now, we'll just look at the common factor being a 12. So when I take out my 12, 12 times what gives me negative 12a? Well, I'm going to have to write negative a right here, right? And 12 times what gives me a positive 12? It looks like positive 1. Okay. Now to simplify this, I look at my coefficients. 3 and 12 can reduce. They're both divisible by 3. So this would give me, quite simply, reducing that. Gets rid of that altogether. 12 divided by 3 gives me 4. I've got an a squared term here, but I don't have any a's out here, so I can't really do anything with that. Looking at my brackets, I see that in order to cancel them, they need to be exactly the same. I've got a minus 1 and negative a plus 1. You might think, oh, they don't look the same, I can't cancel them off. But what I think you may notice is that the difference is that this is the a is positive here, here it's negative, here the 1 is negative, and here the 1 is positive. So it looks like the signs of each thing, each term here, are just reversed. So whenever you run into this instance where you just have signs reversed, the way that you can rewrite the terms so that they can cancel is to factor out a negative 1. So let's just consider negative a plus 1 for a minute over here. If I'm going to factor out a negative 1, I put the negative 1 out in front of a set of brackets. So negative 1 times what gives me negative a? Well, that would have to be positive a now. Negative 1 times what gives me a positive 1? Well, this has to be negative 1. So I can see then that this can turn into having the same bracket as the numerator. So I'll rewrite things to make them look a little nicer here. So I've got a squared times a minus 1 over 4. And I'm changing this one up to be negative 1 times a minus 1. And now I can see that these brackets can cancel, leaving me with a squared over, down here I've just got 4 times negative 1, which is negative 4. And then just to tidy it up, we don't usually like to write the negative inside the denominator like this, so we'll usually write it as just negative out in front of the fraction. So negative a squared over 4. And that's the final answer for that one there.